Okay, there we go. Hopefully this is working. I was having some video problems again. So this is week 4, lecture 2, I guess, and we're going to cover in the next few video lessons truth functional entailment and truth functional validity. So remember, everything we've been doing up to now for the past week or so is using this notion of a truth table to more rigorously and more formally study the variety of different concepts that we had informal notions of. So we had things like logical truth, logical falsity, logical equivalence, and all of these notions we sort of talked about informally, and we used our intuitions about which things were logically true and whatnot. Now we've been looking at these in a more formal manner by using things like truth functional truth and truth functional falsity. And if you remember, at the end of our sort of informal discussion, we talked about validity. And so we said an argument was valid just in case, if the premises are true, the conclusion must be true. And so now we're going to give a rigorous definition of entailment and validity. And so let's start with our notion of entailment first. So this is what we're going to call truth functional entailment. We start out with a set of sentences, and this little sort of this Greek letter named gamma, which it just sort of looks like the letter T with the sort of left side of the T cut off. It looks like a scary symbol maybe at first, but we're going to be using gamma a lot. So whenever you see this symbol with the T sort of taken off, you should read in your head gamma. So whenever you see the symbol, just think gamma. And gamma is just a set of sentences. And remember, all we said that a set was a collection where you didn't have copies of things inside that collection anymore. Okay, so gamma is just going to be some set of sentences. And the kind of sentences that are allowed to be in this set are sentences of SL. So these are going to be sentences that are of the form that we described earlier in terms of the grammar of SL. Okay, so we're going to say that a set of those kinds of sentences truth functionally entails another sentence P if and only if there is no truth value assignment on which every member of gamma is true and P is false. So that's a bit of a mouthful, and that might be a little bit confusing. And going over an example will probably help make a little bit more sense of this. And then we'll come back to this definition to see why it still works, or how it works. So suppose that gamma is this sentence here, this set of sentences. So there's two sentences in here, right? We have an atomic sentence, A, and then we have a complex sentence. And this complex sentence is a conjunction. So we have B and C. So that doesn't mean there's 3 sentences here, right? The set gamma contains 2 sentences. And we know that we separate the sentences in sets by using the comma. So gamma is a set that has 2 sentences in it. Okay, well, we say that gamma, so this set of sentences, truth functionally entails B. So this is B, notice, is B is not a sentence in this set. So how are we going to make sense of this, or how can we discuss this using the definition that we have up here? Well, we can use a truth table to show that this sentence, B, is truth functionally entailed by this set of sentences right here. So here's what we do. We make our truth table that includes the sentences from the set of sentences. So we have here the sentence A, and we have the sentence B and C. And then we're also going to look at this sentence here, B. So we're going to put that up here as well. So even though B here you can think about it as our conclusion. But we're going to check to make sure that B is in fact entailed by this set of sentences. So by convention, we usually take the sentence that is entailed by the set all the way to the right. So now what do we do? Well, the first thing we do is we evaluate gamma, right? So we look at each of the sentences in gamma and we evaluate their truth values according to the different truth value assignments. And remember, a truth value assignment is just a particular row of the truth table. So here, I've just iterated this, all the truth values for A under all the different truth value assignments. So this is just a copy here from this column. And then we need to evaluate B. And in the interest of time, and me being lazy, I didn't write them all under B, and I didn't copy all of the truth values under C. And like I said before, you yourself don't have to do that either, right? What's really important is just that you capture the connectives. So if it helps you, then you should do it. If not, then if you're getting too bored and it's getting too easy for you, then it's not required that you do it. Okay, so here I've filled in the truth values for this sentence B and C for the different truth value assignments. So here the sentence is true because both B and C are true. And by the definition of conjunction, the complex sentence is true just in case each of the conjuncts are true. And so here we get false because C is false. On this truth value assignment, the whole sentence gets false because B is false. Here the conjunction is false because both of the conjuncts are false. Here we again get it that it's true because both of the conjuncts are true. And then again, false for the rest because in each of these scenarios or under each of these truth value assignments, at least one of the conjuncts ends up being false. Okay, so now what we need to do is we need to look at those rows or those truth value assignments where both of these sentences are true, right? Because our definition says a set of sentences of SL truth functionally entails a sentence P if and only if there's no truth value assignment on which every member of gamma is true and P is false. In other words, what we need to do is we need to go look at the truth value assignments where every member, I misspelled member there. Let me go ahead and fix that. You'll notice that I'm using a slightly different, I'm not using a regular text editor anymore. I've actually gone ahead and I found a new program of what's called LaTeX, and it updates a PDF automatically. So this is me trying it out because it's much nicer. Okay, so we have the set gamma, and what we want to do is make sure that on every truth value assignment where the members of gamma are true, we want to make sure that P is true on those ones as well, right? Because we're saying here that the set gamma entails another sentence P if and only if there is no truth value assignment on which all the members of gamma are true, but P is false. So in this case, gamma is our set of sentences A and the sentence B and C. And what we want to make sure is on every truth value assignment where both of these come out true, does B come out true as well? And if so, then we know that gamma truth functionally entails B. If we can find a truth value assignment where both of these sentences are true, but B is false, then we know that gamma does not truth functionally entail B. So let's have a look. So the rows that we need to look at are those rows, or again, those truth value assignments where both of these sentences are true. And lucky for us, there's actually only one row we have to check here, right? Because here, B and C is false, here and here, B and C is false, and we don't need to look at this row right here either because A is false on this row. So the only rows we need to go look at are the ones where all of the sentences of a set are true. And that happens to be this first row right here because A is true here and B and C is true here. Okay, so now that we've identified all the rows where the set of sentences are true, then we need to check to see whether or not B is true there as well. And it turns out that it is. And since there are no other rows to check, this in a sense passes the test for whether or not B is truth functionally entailed by gamma. Okay, so far so good. We also have a notion of saying when a set of sentences is not truth functionally entailed. Or sorry, when a sentence is not truth functionally entailed by a set of sentences. So let's look at this case. Suppose that gamma is this time equal to the set of sentences that contain A and this sentence B or C. We say that the sentence gamma, or sorry, the set of sentences gamma does not truth functionally entail B if it fails to meet this condition, right? Namely, if there's a truth value assignment on which every member of the set is true, but P ends up being false, right? So your conclusion, if you like, then you know that that sentence is not truth functionally entailed by the set gamma. So here we're going to let gamma equal A, we're going to let gamma equal the set of sentences that include A and the sentence B or C. And I guess I haven't introduced the symbol yet, but when we say that a set of sentences like gamma does not truth functionally entail B, we use this little symbol here. So this is a double turnstile with a slash through it. So we're saying it's not the case that gamma truth functionally entails B. Up here we have the double turnstile without the slash. And what this symbol means is gamma, where gamma is going to be a set of sentences, truth functionally entails B. Okay, so the claim here is that gamma, when this set of sentences is equal to gamma, gamma does not truth functionally entail B. And we can check this with the following truth table. So again, I've just copied A here, and I've copied B here, and then I've filled out the values for this sentence, B or C, based on the different truth value assignments. So it's true in this row because B is true, it's true in this row because B is also true, it's true on this row because C is true, and remember, disjunction, you just need one of the two to be true. So the only times when the disjunction is false is when both of the disjuncts are false, and that happens here on this truth value assignment, and that happens down here on this truth value assignment. Okay, so now what we need to do is we need to make sure that on any given row where each of these sentences is true, right? So we want to look for all the rows where the sentences in gamma are true. We want to make sure that B is also true on all of those. And oh, I can already see that I actually didn't copy B here. I kind of lied. But this will be instructive. So we look here now. We need to be looking at this row. We need to be looking at this row. We need to be looking at this row. And that's it, right? So we just need to be looking at those rows, or in other words, we need to be looking at those truth value assignments on which both of those sentences come out true. So up here, we see that B comes out, B is true, and B is also true on the second one. But there's one more third row that we need to check, and that's this one right here. And B is actually false on this one. So let me go ahead and actually fix that. Okay, so that should show up in a second here. Oh, I was actually changing the wrong one, shoot. There we go. Okay, so we're good in the first case, right? Because these sentences are true and B is true in those cases as well. But here, both sentences are true, but B is false. So we know that this set of sentences, A and B or C, does not truth functionally entail B. Why? Well, because we found a row where the set of sentences are true, but B is false. Okay, so hopefully that makes sense, and hopefully I didn't confuse you too much with trying to use some of this new stuff. If there's any questions or if there's any difficulties, please feel free to comment. And in the next lesson,